Here's another vector question. We've got a parallelogram. We're told that P is on AC such that the AP distance is 2/3 of the whole lot. We're given the fact OA is 6A and OC is 6C. So everything will be in terms of vector A and vector C. They want us to find OP, which is this guy here. So we need to find a journey that does the same as the journey from O to P, but along lines we know. I think the first thing to do is to work out the vector AC. The vector AC will be the same as going the wrong way along OA and the right way along OC. So first of all, I can say that AC is equal to the wrong way along OA, which is -6A, plus the right way along OC, which is plus 6C. So if I need to do this journey from O to P, I will need to travel along A to P. And because we've been given the ratio of AP to the whole lot AC, I can say that AP is 2/3 of this lot. Multiplying this bracket out, the 3 will cancel with the 6 in both occasions, leaving 2. So I get -4A plus 4C. Right, OP now. To travel along from OP, we need to go up 6A and then the vector we've just found. Therefore, OP is equal to 6A plus this lot. We can put the A terms together to be 2A plus 4C. And that is your answer. We're now told that the midpoint of CB is the point M, and we're asked to prove that OPM, which is the line which will continue the OP vector, is a straight line. OPM is a straight line. We're asked really to show that the gradient of PM is the same as the gradient of OP. I talk in terms of gradients because in a way A and C, the directions of both of those original vectors, will determine the gradient of every line. So I'm looking for the fact that PM will have a C component which is double that of the A component. So how do we find it? So if we do the journey from P to M, we should be able to find the relationship between vector A and vector C. So to do the journey from P to M, we've actually got to do 3 journeys. We've got to go backwards along AP, then forwards along AB, and then downwards along BM. Let's work out what each of those components are. So I can say the journey from P to M will be equal to, right, first of all, we're going backwards along the answer we found for part A. So it will be the negative version of this guy here. So this will be plus 4A minus 4C. So we're now here. We now go along AB. And because we're told our shape is a parallelogram, this vector here will be the same as OC. So we're plus 6C. And again, because this is a parallelogram, CB will be the same vector as OA, but we're only going halfway. So this will be -3A. So gathering the A vectors together, 4 take away 3 will just leave us with A. And the C vector, 6 minus 4 plus 2C. Now, if you compare OP and PM, remember these are the 2 bits of this hopefully straight line, you can see that PM is 2 times OP. This means they have the same gradient. And as they share a common point P, the line must be straight. So writing that down as 2PM equals OP, and P is common. Therefore, OPM is a straight line. And there you have it.